and today we will see the topic freshwater generator. And first of all, what is freshwater generator? And freshwater generator convert the seawater to freshwater, and this is mainly used in ship. And then what is the uses of freshwater generator? To produce the freshwater from the seawater. And the freshwater uses is cooling system and other domestic purposes using in sea. And the cooling system, and mainly cooling system is to maintain a cooling to the engine. In main engine there is a cooling system is there, and engine outlet water is going to the freshwater generator, and the freshwater generator inside, and after the freshwater generator the water going to the jacket cooling water cooler, and then jacket cooling water is a cooler to transfer the heat from the low medium to higher medium. Then the water going to the freshwater water pumps, jacket cooling water pumps, and then it going to the main engine. This is a closed loop system. It's a running loops. And after we will see the inside the freshwater generator systems, and there is domestic water uses and drinking and cooking. In ship we have only for this system only, and drinking also and cooking also, and washing and sanitation, and hydrofoil system. And hydrofoil system is the pressurized system to maintain the water pressure to the various of onboard users and including the domestic needs. And hydrofoil system is construction is it's a closed vessel, and inside we have to maintain the water pressure and air pressure. So the water pressure is automatic pressure limit switch is there. Once water getting a pressure and the limit switch is on, the pump is cut off. Then drop the pressure and water pressure. When it drops the water pressure, the pump will get activated. The water getting inside the hydrofoil system, and this is the system is different. And then the air is going to the hydrofoil system, or it getting pressurized. And this is the system. Here we can see this system both and freshwater and seawater types, and maintain the water pressure for various onboard users including domestic needs. Then cooling systems, and cooling system we are already here and seen. This is the main engine cooling systems. Then fire, we have to isolate the fire from the places. Then boiler feed, and average each crew member using about the 70 liter of water per day in onboard in a ship. It's maximum per day we are using 15 to 20 tons of water in daily uses, and cooling and personal and other cleaning uses. And principle of freshwater generator, and there is two. One is reverse osmosis and one is distillation. And reverse osmosis is a domestic purposes we are using, and reverse osmosis is very less amount of water production is there, and distillation is using in ship for huge amount of water production, and per day it will product 10 to 11 tons. Now we will see the distillation, and distillation is the process of separation freshwater from the seawater by boiling of seawater in evaporator, and the evaporated vapor gets condensate in the condenser. And distillation there is two parts for heat exchanger: evaporator and condenser. Evaporator for get the steam, and condenser for get the cool to water. The boiling of seawater is done by the jacket cooling water, and increase the overall efficiency. And already here the engine outlet water is going to the fresh water. So engine outlet temperature is in around 80 to 85 degrees Celsius. It's going to fresh water. And here also this water is mentioned. Chip boiling seawater done by jacket cooling water, which will increase the overall efficiency. But as you know, the jacket cooling water at the 80 degrees Celsius cannot boil the seawater at the atmospheric pressure. And normally atmospheric pressure 1 bar and water is it will get for boiling for 100 degrees Celsius. But in the freshwater generator we will create the vacuum for the better boiling point. So here, in order to boil the water at 80 degree, we need to reduce the atmospheric pressure. And once we reduce the atmospheric pressure, water get boiling at a low temperature, means below 100 degrees Celsius, and which is done by creating the vacuum inside the chamber where the evaporator is taking place. When the vacuum takes place, the water get boiled. And there is two types of water generator, and one is plate type freshwater generator and tube type freshwater generator. And then this jacket cooling water, there is a two types, and one is HT water and other one is LT water. And HT water is high temperature water and LT water is low temperature water. And HT water is cooling in that main engine here. HT water is main engine cylinder's head side is there, and LT water is the other cooling parts, and scavenger air cooler and low boil cooler, and other cooling system is LT, and high temperature is HT. Why is called here HT? And cylinder, power stroke and exhaust stroke. In these two strokes the cylinder get high temperature above 450 degrees Celsius. So the water getting too much hot in this place, so we are using, this is a recovery types, we are using this water is here, that engine outlet water is, it's the inlet of fresh water. Here this jacket cooling inlet water is, it's going to the evaporator side to the freshwater generator. And first type we will see plate type freshwater generator, and other one is tube type freshwater generator. And plate type freshwater generator, the condenser and the evaporator heat exchanger is there. Plate type means the heat exchanger like a plate. Thus there is a number of plate arrangement in the evaporator side and condenser side. There is a different parts also there. Main components are condenser and evaporator, I already told. Heat exchangers, these two is heat exchangers, then drain ejector and seawater pump and distillation pump and salinometer and demister water flow meter. This is the other parts. First we will see the heat exchangers. And condenser and evaporators are made by a titanium plates to for better heat exchanger process, because we are using titanium plates. Then drain air ejector, it is used to remove the air drain from the chamber, which helps in the maintaining the vacuum. So here already seen the seawater getting boiled at the 80 degree Celsius. It's normally 100 degrees Celsius, and when we are create the vacuum inside the chamber getting 80 degrees Celsius at the boiling point. Then seawater and distillate pump, and both are centrifugal pumps. And seawater pumps is seawater inlet pumps, and distillate pumps helps to pump out the fresh water to condenser, and seawater pump supply to the seawater to the condenser and evaporator. So the freshwater distillate pump is to send the freshwater tank, and the seawater pump supply the seawater to the condenser and evaporator tank. And demister, it's help to remove the carrying over the seawater droplets and water spray. It is made of layered kinetic wire of non-metal, and the main uses is it's prevent the water droplets, because it can go to the condenser side, because we are preventing this water molecules in between the evaporator and condenser side. And salinometer, and check the salinity of the water. The main function is to check the salinity of the water. That is a three-way valve is controlled by the salinometer. So if the salinity is high and water goes back to the evaporator inlet, or otherwise the system is different, means it's going to the overflow. When the salt level is higher, it sends the salinometer. The salinometer is like a three-way valve, and the valve is open, then the water is going to the, and one type is evaporator inlet and another one is overflow. And the BPM is normally 10 ppm. Salinity usually maximum 10 ppm, and normally we can get an alarm in 3 to 5 pm. And plate type freshwater generator, this is a drawing, and this is a closed chamber, and this is the blue line is evaporator side, and the green line that in this part is condenser side. And this is the air brine ejector, and this is the distillate pump to supply the fresh water to the freshwater tank, and this is a seawater pump to supply the seawater to the systems. And first the seawater is going to the condenser, then it going to the air brine ejector, and there is one line, it's the and condenser side the seawater getting little bit hot in this side, and after the seawater going to air brine ejector, and between there is one line, this line is going to the evaporator. Here jacket cooling water inlet going inside. So the jacket cooling water also at 80 degrees Celsius, and inside the chamber we already create a vacuum by the air brine ejector. So here the water getting hot and boiling temperature also attained, and once the seawater evaporated, the evaporator going to the condenser between the demister, means by the demister. Here we can see that the remaining of seawater is drained to the brine in bottom of the chamber. Here the brine, the water also coming out, the air also coming out, because it's system getting vacuum. And the blue line is jacket water, and the green line is seawater, the light is distilled water. Distilled water means our fresh water, then air extraction, then vapors. This yellow line is considered as a vapor lines. So once seawater getting hot, that evaporates will create the evaporates going the condenser side. Then in the condenser side, the evaporator vapors getting cooled, so the vapor stage again it converted into the liquid stage. Here the fresh water getting outlet by the distill pump, and here we can see the salinometer and three-way valve. And already we seen salinometer purpose is to check the salinity of the water. The three-way valve is controlled by the salinometer, and salinometer once sets the ppm high, the three-way valve is activated. Once three-way valve activated, the water going to again evaporator stage, and again the process is starting here, evaporator system. Again it getting evaporate from the evaporator, so again it's going to condenser, then getting cool, then again it's going to salinometer. And this is the basic concepts and system, this concept. Then here working, and main engine jacket water passes through the evaporator at 80 degree. Feed seawater enter the evaporator through a orifice at the feed inlet. Due to low pressure in the chamber, seawater boils and get converted to steam. Due to low pressure and create a vacuum, low pressure in the chamber, the seawater boils and get converted to steam. And these lines are happening here in evaporator. The carry over the water droplets, then the carry over the water droplets, and water spray is removed by demister, and demister is here, and this is demister. The carry over the water droplets and water sprays is removed by demister. Then the separated water droplets get collected as brine, which is exerted by brine ejector. Then the steam then enters into the condenser. Here in the evaporator side, the remaining seawater is going to the brine stage, air brine ejector. It's going outside. The steam then enter into the condenser, and where it get cooled down to from the fresh water. Then after cool down the vapor, it will get liquid stage. Then after the water going to the distill pump by the distill pump to the freshwater tank. And this is the plate type, and another one is a tube type. And what is the difference between plate type and tube type? And plate type, there is a plate types of number of plates and fixed in these systems, that water passing to the between the plate, and between the plates the water passing. And tube types is there are number of tubes fixed in the system. This is the difference between the plate type and tube type. And tube type freshwater generator, and working and principle of tube type freshwater generator is same as plate type. And the working and principle of tube type freshwater generator is same as plate, and only one difference, that is we are using plates and here we are using tubes. and condenser side and evaporator tubes. Here condenser side also we are using tubes, and evaporator side also we are using tubes. Here typically in diagram tubes freshwater generator is given below, and this is a tube type, and this is here evaporator and this is condenser, and here also jacket water inlet 80 degree and outlet 60 degree, and water getting boiling point at a 80 degree Celsius. So after this is only after create the vacuum. After we create a vacuum, then the water getting boiled, and once evaporator going to the condenser tubes, and here also between the chemistry is fixed, and then it going condenser tubes. And here air drain ejector is fixed. This is seawater pump, and this is display pump. The seawater pumps supply the seawater to the condenser side. Then the condenser side, air drain ejector side also it's here fixed. Then it's create a vacuum inside the chamber. In the cooling system, the HT water is going to the freshwater. I already told we don't need the freshwater generator, then we can bypass this system. And when we are sailing, that time also we will start the freshwater generator. And when we are anchorage and nearest port, we don't need this freshwater generator, so that time we can bypass this system. So that time the freshwater HT water is going to direct to the cooler, then going to the pump, then it is going to the main engine. This is without freshwater